All right, so we're back in section 6.6. We're going to take a look at some of the problems herein and take a look at the multiple types of factoring that may be required in any problems. Now, these types of questions have been peppered into the chapters 6.1 through 6.5, but most of the problems contained herein in this section typically do involve multiple types of factoring. So in all the questions that we're going to look at here for this section, we're going to keep this chart handy on the side to show how this chart can be used as an organizational tool to help us narrow down the types of factoring that can be applied. So having this kind of criteria on the side will really be helpful in helping us to make decisions for the factoring decision process. This type of chart you will also find is highly helpful in the work that we do in Chapter 7 when it comes to factoring, because as we have to simplify rational expressions, you may have multiple polynomials to simplify. In deciding how to best simplify those polynomials and what techniques of factoring to apply, this chart will be extremely helpful. So let us go ahead first and let's take a look at question number 13. We have x to the third minus 5x squared minus 25x plus 125. So first thing I want to do is I want to look at this and I want to determine, does it have a greatest common factor? So as I look at the numbers, I see the first term automatically has a 1, so I know number-wise there's no greatest common factor. I look to see if all the terms now have a common variable. All of them have an x except for the last term. So because there's no common number that's the greatest common factor, and because there's no common variable that's the greatest common factor, we can exclude having to factor the greatest common factor for this. So at this point now, we say, okay, we have 1, 2, 3, 4 terms, and we realize that most likely the type of factoring that's going to be involved in this question is going to be factoring by grouping. So let's go ahead and apply factoring by grouping to this. So I'm going to split it up as I've done in other videos here. This is going to be x to the third minus 5x squared. This will be negative 25x plus 125. And I'm going to go through this a little faster because I am making the assumption if you are starting here first that you're already pretty comfortable with factoring but maybe need a refresher. If you need more reflection time and more build up to this, please go back to this other sections that were offered before going further here. For x to the third minus 5x, the greatest common factor is x squared, and the resulting factor on the inside will be x minus 5. For negative 25x plus 125, we have to factor out a negative, and we have to factor out 25 as the greatest common factor. So I'm going to factor out a negative 25, and because I factor out a negative, I'm going to make this positive, this negative, and this will give me x minus 5. So rewriting this, I'm going to get x squared times x minus 5 minus 25 times x minus 5. And now, when I factor out the common factor of x minus 5, I find I have left inside x squared minus 25. Now, normally in most problems, I would take x squared minus 25, or I would just leave it at this. However, x squared minus 25 is now the difference of perfect squares. So when you're doing questions like this, just because you come up with these factors doesn't necessarily mean you have to stop. But if you're looking at this binomial, remember, it's a binomial. So we may have to look at these three different factoring techniques to think, how can we do this further? So since it's the difference of perfect squares, I can go ahead and I can write x minus 25, or x squared minus 25 as x plus 5 times x minus 5. So we have the three factors now of x minus 5 times x plus 5 times x minus 5, or I can rewrite this now as x plus 5 times the quantity of x minus 5 squared. And you'll note in the section of 6.4, we went over where if we had the same binomial appear more than once, how we could write that as that binomial quantity squared. Going on to the next question here. Just looking at a question here. And yes, my wife is not here. She just sent me a text saying she had to take off. So let's go on to question 25. This is going to be 5x to the 5th minus 80x. The first type of factoring, again, we're going to always look at the factor, is a greatest common factor. So we have 5 and 80, so the greatest common factor of that is going to be 5, and x to the 5th, and x will be x. So when we factor out 5x, this will give us x to the 4th minus 16. So first we factored out the greatest common factor. Now we need to look further and see if there's any other type of factoring we could bring here. Well, we do have a binomial, and it looks like because x to the 4th is a perfect square and 16 is a perfect square, that we'll be able to use the difference of perfect squares. So we're going to go ahead and write out x to the 4th minus 16 and the pair of factors of x to the square, x squared, plus 4 times x squared minus 4. So looking at this now, we see we have x squared minus 4. This is also the difference of perfect squares, so we need to factor this further. So we can factor this further into x plus 2 times x minus 2. So now we're going to bring this down. So when we write down all the factors, we now have 4 5x to the 5th minus 80x, the factors of 5x times x squared plus 4 times x plus 2 times x minus 2. And these are all of the factors that represent the quantity above. Let's take a look at another problem. We're going to take a look at number 30. And this is going to be negative x to the 5th plus 4x to the 4th minus 3x to the 3rd. So in looking at this question, since we're looking to factor out a greatest common factor, the first thing we should recognize is that the first thing that has to be factored has to be a negative. Because the first term begins with a negative, we need to factor a negative out of this first. So once we factor out a negative, before anything else, I would go ahead and change the signs of everything on the inside and make that a practice, because if you try to factor out anything else out first, you may forget to switch the signs. So for x to the 5th, x to the 4th, and x to the 3rd, the greatest common factor is going to be x to the 3rd. So going through, x to the 3rd times x to the 2nd will be x to the 5th. Bring down the 4 because there's no greatest common factor that's a number. X to the 3rd times x will be x to the 4th. And then x to the 3rd times 1 will be x to the 3rd, but we bring down the 3. So rewriting this now, we'll have negative x to the 3rd times x squared minus 4x plus 3. Again, I've gone over the techniques of factoring this trinomial. Since we have a trinomial, we need to look here. It's going to have to be factored into two binomials. Fortunately, because the a coefficient is equal to 1, the type of factoring involved will be pretty simple. So if I take a look here and I form my triangle from this, so I have a times c and b, I need two numbers whose product is positive 3 and whose sum is negative 4. Well, the only two numbers that give us this are negative 3 and negative 1. So when I write the binomial factors for x squared minus 4x plus 3, this will give me x minus 3 and x minus 1. Again, if this technique looks very different to you, please look at my sections in section 6.2 and 6.3 for a thorough explanation of this, and this will also be covered in class. Also, please remember to bring down the negative x to the third and have the equal signs here. So now we have the three factors of negative x to the third times the quantity of x minus 3 times the quantity of x minus 1, which are the three factors that represent the problem in number 30. Let's see if we can squeeze another problem in on that page. So really what we're trying to send here is look at all the multiple types of factoring we have. First, we have a negative that we need to factor out, and we need to change the signs of everything as we do so. We also have a greatest common factor of x to the third that needs to be factored out. We get a resulting trinomial, which we need to then factor into two binomials. So even though factoring the negative is a greatest common factor, it's a special type of factoring that we do only when the first term of a polynomial has a negative value or negative coefficient. So let's take a look now at one type of trinomial that looks like a lot of fun. This is going to be question 55. 8m to the third n minus 32m squared n squared plus 24m and n. So again, first thing we want to try to do is we want to try to look for the greatest common factor. When we do that here, we'll just look for the numbers first. For 8, 32, and 24, the greatest common factor is going to be 8. For m to the third, m to the second, and m to the first, that will be m. n to the second, and n, that will be n. And let's just see what results. See if we have to move anything around, perhaps. So, first when we factor 8 out, that's going to give us 1 here. That's going to give us 4 here. That's going to give us 3 here. I don't need the 1 here, but we can clean this up later. We'll just put it there to hold it. M times m to the second is m to the third. M times m is m to the second. M times 1 is m. Don't have to put a 1 here. I have a 3 here already. N times 1 is n. Don't need anything there. N times n is n to the second. N times 1 is n. So we have this left on the inside. So we have 8mn times m squared minus 4 I'm just checking my work to see if I wrote down the problem correctly. And it looks like I have. 4mn plus 3. At first, if you're looking at this problem, you might want to believe that you could factor this. Here's only one thing holding it up, is that there is an n here. Because of that, this is not factorable anymore. Otherwise, you may be able to factor this trinomial into two binomials. But there's no way to get this n out, and there's no way to factor it further to get this combination of m times n. We need to multiply something to get that. So we cannot get this middle term. So there's no way to factor this any further. Let's take a look at another problem. Just a couple more to emphasize this point here. Let's take a look at question number 65. This is going to be x to the 6th plus x to the 5th y minus 2x to the 4th y squared. So I see where this question is going, and once we factor out the greatest common factor, I did go over a question like this earlier, I believe in section 6.2 or 6.3. but it's worth showing one more again to kind of reinforce the basic ideas here. So again, we're going to look for the greatest common factor, and because we have x to the 6th, x to the 5th, and x to the 4th, the greatest common factor is going to be x to the 4th. So once we factor that out, we get x squared plus xy minus 2y squared. So when we look at this, how do we factor it? Well, we have to remember that we can still, in this trinomial, and especially because we have an a coefficient of 1, we still look simply to the coefficients, and because it begins with an x squared, we write x here. It ends in the y squared, we write y here. And we're just going to try to figure out what are the signs and the numbers that are going to go here with the x technique. So we have an a of 1. We have a c of negative 2. So a times c is negative 2 here. And we have a b value of 1. So we're looking for two numbers that have a product of negative 2, have a difference of 1. So that's going to be positive 2 and negative 1. So here I'm going to put x plus 2y and x minus, I could put 1y, but all I really need is y. So I will write it as x times x plus 2y times x minus y. I will work with most students in class on several of these problems to help students refine their technique in this. But these are the techniques that are going to be necessary for students to be successful in the work, especially in Chapter 7. Because even within simplifying rational expressions, you may have more than one technique in factoring that you may want to utilize. Please bring your questions to class and be sure to share your comments at the end of the video to see if you may want more examples or if you have any questions about the content. Thank you.